let's take a look at this example. In this example, we have a scatter plot that shows, looks like car vehicles. It has the car's weight. I would imagine that's in tons along the bottom, and their miles per gallon up on the y-axis. So, well, first thing I want to do is, the question says, what would you predict about a car that weighs 8 tons? Well, the scope of my problem only goes from, I don't know, like from 1 to maybe 6. So this is going to be just slightly outside of the scope of the problem. But no worries. First thing I'm going to have to do is I'm going to have to find the equation for the line. So how do I find the equation for this line? And really, this is just a little trick here. And I'm just going to try to find two values. So I'm going to put a line straight up from 2. And I'll put a line straight up from 4. Okay, so where does this line touch? So go straight up from 2. So if I put in another line, this one I'll go left and right. This one. Alright, so this point is what? This is going to be 2, and I would say that height is going to be, so maybe 26, between 25 and 30, so maybe 26. And this point down here is going to be 4, and I don't know, maybe 16, something like that, maybe. I think that's going to be close, maybe 15 and a half. This 26, actually, you know what, I'm going to change that 26. I'm going to change that to 27. I think that's a little bit further along than this one is. So if I'm only going up 1 there, I'll go up maybe 2 there. So we'll call it 27. The halfway point would be, what, 27 and a half? Okay. So I have the 2 points, 227 and 416. So to find the equation of the line of fit, I need to find the slope. So the change in y, so 27 minus 16, is on top, and the change in x, 2 minus 4, is on bottom. So negative 11 over 2, which negative 11 divided by 2, I'll turn that into a decimal, is negative 5.5. So that means the slope is negative 5.5. And to find the y-intercept, I would have to do an equation of y equals y minus y1 equals m times x minus x1. So let's do the x minus x1. Actually, I'm going to do y equals mx plus b. So to find the y-intercept, if I do y equals mx plus b, and I know my y value is 27, equals negative 5.5 is my slope, times my x value of 2, plus b. So negative 5.5 times 2 is negative 11 plus b. And then I add 11 to both sides, 38 is B. So let me just double check my math there. That'd be negative 11, that's good. Add 11, looks good to me. So 38 is my y-intercept. So here is 38 and my 38. All right, so find the equation of the line, the miles per gallon. And again, I should probably put this on. Does have a hat on there. Those do have hats because they are estimates for miles per gallon, not actual. So if the equation is negative 5.5 times the weight plus 38, and I want to know, the question says, what would you predict about a car that weighs 8 tons? So I'll just plug 8 in for the weight. So calculator, so negative 5.5 times 8 plus 38 is negative 6. And that is miles per gallon. So what does that mean? That means if a car weighs 8 tons, it would get negative 6 miles per gallon. So before even starting it, or if you went 1 mile, you'd get negative miles per gallon. I don't think that's possible. So we've got a big problem here. I want you to think about why is this answer. First of all, miles per gallon. If you drive, you're going to get some sort of positive miles out of a gallon of gas. It's not like you start driving and you go backwards, right, and lose miles. So miles per gallon has to be positive, yet when we use the regression equation, it's negative. And the reason for that is, think about where 8 would fall, right? In the scope of this problem, my data is ranging from like 1 to 6, but 8 would be way out here. So I'm talking about a problem in which you start looking at finding a value that is outside of the scope of the problem. And we talked last chapter about this, what we call extrapolation, and why we have to be super careful with it.